All right, welcome back. I have handed the tests back. The median grade, what does the word median mean? Middle in what way? The one in the very middle. After you do what? Is it? I don't think we need to take out high and low. What is median? That's called the mean, when you add them all up and divide. It's not necessarily that kind of a thing. Okay, so if we put them in order. All right. I'm just trying to give you guys a sense of where you stand in this class on this test. If we lined everybody up, highest to lowest, and we looked at the person in the middle, then that grade right there is called the median. The median grade on this test was a 72. Okay? Half of you guys got a grade higher than 72, half got something lower than 72. All right? Median. There's our median. Okay, so what to do? All right, the semester is winding down, but there is still time for you to change the grade that I put right there. So it's a snapshot. It's at this moment in time, but it can go up and it can go down. If you want it to go up, take a look at all the numbers that are in here. This is like an easy thing to diagnose. If your in-class activities are low, it's because you're missing too many classes. Come to class, don't miss anymore, and that number will go up. If your daily questions are low, and for some of you, they are very low, it's because you haven't been turning in the questions of the day. Now, I dropped the two lowest, but every time you turn in questions of the day from this point forward, that number goes up. If you miss some, that number goes down. It's something you have control over. So make a choice. Do it if you want it to go up. If it's okay if it goes down, then you don't need to do it. Projects. Okay, many of us did revisions and got grades that went up, which is great. There is one more project coming up. It is technically not due until the last day of the, until the day of our third exam. But if you want me to give you a chance to revise it, you got to give me some time to grade it and give it back to you, okay? So there's another project coming up. If you want everything to go up, then do good work on that second project. It'll be a really, really good project. The last one, this test one, this is the one that you kind of have less control over. So you're going to study as much as you feel like you need to study. You're going to do as well as you can do, but that's based on your performance in a 60-minute classroom setting. But the other things you have control over, more control over, different control over. So there is still time for those numbers to change. There is still time for this red question mark to go up or down. Make some good decisions as we wind down the semester, okay? If you have individual questions about your test, I have office hours right after class every day. All right, the other thing, so we'll pull up our calendar here. You can see I've highlighted 6 classes. There are 6 days left of new material in this class this semester. That is all. I say that for 2 reasons. Number 1, I want to give you a sense that we really are coming to the end of the semester. And number 2, the second test and the first test were on 8 days of material. The last test is on only 6. That's significantly less. So I'm not saying it's easier, the last test. I'm saying it's on less stuff. Okay, Charlie? So the tests are 40%? No, the tests are all 40% total, all equal. Yeah, it was a while ago. It's a good question. Okay, officially your plan for project 2 is due now. Some of you handed it to me on Tuesday. I haven't had a chance to look at them yet. I was busy grading your tests, so hopefully the plans are in the folders. If not, look at the list of suggested topics for project 2. They're in packet number 2. Give me a plan, when we come back on Tuesday next week. Okay, so the calendar is up here. This last group of 6 things does not have as much, it's not as joined together as well as some of the other, we had some kind of major themes in the course earlier. This last 6 is kind of like a smorgasbord of math stuff. So the first class, we're going to talk about math and nature. Second class, a little bit more nature stuff as we discuss populations. And then in the third class, we'll talk about fractals, which maybe you've heard of, and how they apply to nature. So a little mini theme there with nature. Then we'll spend a day talking about music and math, and then the last 2 days talking about math and art. We have our review day is the last day of our class, and then our test number 3 is during exam week. but it is not a cumulative final exam. It is just our third test. It happens to be during exam week. Mark it in your calendar. It's May 15, 10:30, right here. Note the different time. We're not starting that test at 11. We start at 10:30. Any questions on anything up there? Okay, so you have in your hands our third and final packet. That's the last handout I'll give you for the semester. It's probably a little bit thinner than the other ones because, again, it's only on 6 days of new material instead of 8. We're going to skip past the first page because later on you're going to rip that off and hand it in for homework. Okay, sorry. Oy. Okay, where is the hole? 4? Yeah. You're welcome. Okay, so this one we'll talk about. It'll be coming up in a coming class. All right, but we skipped that page. There's another thing. There's a nice picture of a desert scene. We're skipping that too, but later on you're going to rip that off and hand that in for homework. But I put them at the start so that it's easy for you to rip them out, okay? We start on page 5. Okay, so we will go to this big group activity in your groups. Can we get Jocelyn to read from female bees? Let's pause right there. That's going to be the important thing for you as you do the following calculations. How many parents does a female bee have? That's 2. A female bee has a mom and a dad. So far, so good. A male bee has how many parents? Just 1. A male bee has a mom. A male bee does not have a dad. A male bee comes from an unfertilized larva. Strange, but true. Okay? So the family tree for all of us, we have a mom and a dad. They each had a mom and a dad, and you can see that everybody has 2 branches coming before, right? 2 parents. But it's not true. There's a difference between the male bees and the female bees. Keep going, Jocelyn. So what I want you guys to do is fill this table in, but let's look at the first few rows together because I've already started to fill them in for you. In generation number 1, there's our original bee. We're going to then look back in time and talk about that bee's family tree, all the parents and grandparents and great-grandparents of that bee. So how many parents does a male bee have? Just the one. It has a female bee. I like to draw a little line or arrow or something just to connect a bee to its parent or parents. Okay, so the male bee has a mom, an F, a female bee. Now that female bee has how many parents? Has 2. A female comes from a male and a female. And then let's look at this male bee. How many parents does that male have? Just the 1, and it is an F. You don't get to just put any letter below it. You have to, like, every bee came from a mom. It may or may not have come from a dad. And then this female bee here, how many parents? 2, the male and the female. I've spaced it out there just to kind of give us room to keep tracing this down. You don't need to be so careful about spacing, but try to give yourself some room. So what you're going to do is fill in the rest of this table. And you're also, after you do that, going to fill in these numbers here at the right-hand side. For example, in this generation, how many bees are there total? 3. 3 bees total. Okay? So with your neighbors, fill in these rows. Real easy place to check and see if your neighbors are on board with each other is to count. And if you ever have any differences in the count, that's a place to look further, okay? Give it a shot. So we filled in this table with bees, ended up with a pattern in the numbers that maybe we'd never seen before. You guys have seen a lot of number patterns before, but this is maybe a different one and probably wasn't one you were expecting to see. But it turned out that to get the next number of bees, you take the previous generation plus 2 generations ago. Or you could say something like, next one is equal to current one plus 1 generation ago. However you phrase it is fine, but just looking for some English way to capture that pattern. The next couple of numbers in the sequence are 34 and 55. I think I meant to ask for the 9th, 10th, and 11th, but anyway, 8, 9, and 10 is okay. I guess 8 is the 21 that you already found. And then for the number of male bees, surprisingly, it's the same pattern, but not quite in the right row. And so I think if you look at your rows, you'll find that the number of male bees is the same as the total number of bees, but it's like 2 generations behind. It's just 2 rows away from the total number of bees. And the same thing for the female bees, except what? It's only 1 row away, 1 generation away, okay? All right, so let's go to the next page, and we'll talk about number 2. Blake. Okay, let's pause right there. All right, so here's some notation, and I want to really make sure that we are comfortable with this notation. So you guys just saw a list of numbers. It started there. 1, 1, 2, 3, 5, 8, 13. Those were the first few numbers in your list, right? And all we're going to do is give a name to those numbers so that I can talk about them. I'm going to say this right here is the first number, and this is the second number, and this is the third, and that's the fourth, and the fifth, and the sixth, and the seventh, okay? I'm just numbering the numbers, which is weird, but it's just kind of like an index, right? I'm just telling you what position the numbers are in. And so to really give a name to the sequence, we're going to use the letter capital F. We could use anything, but I'll use F for Fibonacci. And so when I say, for example, F6 equals 8, it means something very special. It means that if you're looking at this list of Fibonacci, sorry, I'm using a word that we have not used yet. Forget the Fibonacci stuff. If you look at this list of numbers and you find the 6th number in the list, what will it be? It will be 8, okay? That says that the 6th number in this list is 8, that's all. The 7th number in this list is 13. I want to make it really clear so we're not confused. The 7 doesn't have a whole heck of a lot to do with the 13. The 7 is just telling you what position you're looking at. You're looking at the 7th position, okay? All right, can you guys tell me what these things are equal to? Just to practice with the notation. F8 equals something. What is F8 equal to? It is equal to 21. It's the 8th number in the list. I stopped the list, but it goes forever. Can you guys fill in 2 more equations, just like this one? So don't say out loud, but just write down 2 equations. Tell me what F9 is, and tell me what F10 is. What is F9? 34. What is F10? 55. It's a very compact way to write something that has pros and cons. The pro is that it's very short and quick to write. The con is that you need to be able to translate it. You need to understand what that means. What does it mean? It means the 10th number in my list is 55. Okay? It's just a real compact way to refer to the numbers in this list. Okay, now we'll go to 4. This is where things get quite hairy. Zach. Other Zach. Sorry. Okay, so gosh, I'm sorry. I don't know why is that the first time we've seen that word today? It is. Okay, so this particular list of numbers is called the Fibonacci numbers. I could talk about the even numbers and you guys would know immediately a list of numbers that I'm talking about, right? The even numbers, you know that list. Okay, well the name of this list is the Fibonacci numbers. And we'll talk about who Fibonacci was in a moment. But anyway, that list is named for him. And now we're going to come up with a general formula. You guys wrote in plain English something like, to get the next number, you take the number from the previous generation and you add the number from 2 generations previous. That's what you wrote in English, something like that. Here's how we write it in symbols. The current Fibonacci number, like a general Fibonacci number, we're going to call it F sub lowercase n. Instead of calling F1 and F2 and F3, which are specific Fibonacci numbers, we're going to think of a general number, F sub n. If, for example, n is equal to 7, then this says F7. How much is F7? It's 13, right? So if n is 7, then I'm just talking about the 7th number in my list, and that happens to equal 13. But now we're making a leap from a specific number, like the 7th number in the list, to a general number, the nth number in the list. Here's where it gets really tricky. In English, you know that to get the next number, you take the previous generation and you add the generation before. If I want to talk about the number in the previous generation, I need to put an n minus 1 right there. Raise your hand if you buy it. Previous generation is n minus 1. All right, I need to sell more. We don't have enough buyers. There's another buyer. Yeah. So the current generation we are just calling n, just to give it like a general name like x. It's something very general. But if you are currently sitting on the n number, then what's a good way to talk about the one just before? Well, it's n minus 1. It's one less. If you are currently sitting on the 7th number, then what number is one before? Is the 6th number. So going from 7 to 6 is like going from n to n minus 1. And then we continue. Close. F n minus 2. Let me write this up here. Do you guys believe that 3 plus 5 is 8? We buy that? All right, let me write it in a different order. Okay, what I am doing is referring to those numbers right there. There was a 3, there was a 5, the next number in the list, 8. Let's translate that into the symbols. The 8 is which number in the list? Is the 6th number in the list. So that is F6 equals, the 5 was which number in the list? The 5th number, F5, plus the 3 was what number? The 4th number, F4. So if you wanted to know the 6th number in the list, which ones should you add up? The 5th and the 4th. Yes? If you want to know the 10th number in the list, which one should we add up? 9th and 8th. If you want to know the nth number in the list, here's the leap. Which ones do you add? You add the 2 that were right before it, the n minus 1 and the n minus 2. The 6th number comes from the 5th and the 4th. The nth number comes from the n minus 1st and the n minus 2nd. Zach. Yeah, if it's a different set of numbers, it'll have a different rule. But for this particular list, that's the rule. I know that this is a leap. I know that there is some uncomfort in going from the simple equation 8 equals 5 plus 3 to the more complicated fn equals fn minus 1 plus fn minus 2. But just keep kind of comparing that guy to this guy and give it some time to sink in. It is symbols, but that right there is the math notation way to say, to get the next number, you add the previous generation and 2 previous generations. Okay, so let's move on to the above. Where are we now? Oh yeah, Justin. Mm-hmm. Yes, you replace all the n's with the same number. For example, if I replace that n with 6, then this n becomes a 6, but there's a subtract 1, and this n becomes a 6, but there's a subtract 2. So if you want the 6th number, which ones should you grab? The 5th and the 4th. You see it? 6 minus 1 and the 6 minus 2. I think that's a nice thing to think about. Yeah. Okay, well, we'll go back to Justin for the above. Okay, so we've had our family tree. How do you start a tree? You start it with some seeds. Literally, that's the math word that we use. So the 2 starting numbers, the 2 seeds, are 1 and 1. And as soon as I give you the 2 starting numbers, If you have enough time, you could find as many numbers as you were interested in finding in this list, right? You just keep adding the two previous ones and you'll get the next number. And you can do it for the next 5 minutes. You can do it for the next 5 years. You can find as many numbers as you want. The idea here is we call this thing a recursive thing. What does it mean for something to recur? It means it happens again. So what are you doing? You're doing the same rule over and over again. What's the rule? Add the previous number plus the two previous number, and that's the rule. And you just keep doing it over and over and over again. So we call it a recursive rule. Okay, so a little bit about Fibonacci, and then we'll play some more with this list of numbers named for him. Doug, 5. Okay, so let's take a look just to give us a sense of appreciation for the Arabic numerals that we are so comfortable with. If you wanted to add these two numbers, these two Roman numerals, you guys know X means what? 10, V is 5, I's are 1s. Is that I in the next row also a 1? Yeah, like this IX is one symbol. It looks like 2, but it's one symbol. What number is IX? It's actually 9. Okay, so they've got different symbols, but it can represent any number with their symbols. And how do you add these guys? Can you just add, like, could you add this column of numbers? No, because the X in the bottom isn't really an X. It's not really a 10. It's part of a bigger symbol, which was the number 9. So this whole idea of column adding goes out the window. And maybe you didn't appreciate how nice that was, but gosh, compared to Roman numerals, this Arabic thing is cake, right? Like it's really, really easy to add up our Arabic numerals. So anyway, that's one thing that Fibonacci did in addition to this list of numbers. He popularized the Arabic numbers here. Okay, we'll keep going. Ashley, the work. Abacus. Johannes.
A certain man put a pair of rabbits in a place surrounded on all sides by a wall. How many pairs of rabbits do that pair a year? It is supposed that every month they get a new pair. Second month on.
Okay, so rabbits are known for being productive, and so he posed this problem 800 years ago. You start with a male and female rabbit. In the beginning, they are baby rabbits. They are too young to reproduce at that stage. You let them grow from babyhood to 1 month old. They're still too young to reproduce at 1 month. They don't start producing until the second month. Okay, so they have 1 month, they're still too young. Second month, they still haven't produced any pairs. But in the third month, we're going to assume that they now produce a pair of rabbits. And in the fourth month, they're going to produce another pair of rabbits. And every month from that point on, that original pair of rabbits is going to keep giving birth to a new pair of rabbits, okay? But then we're going to play the same game with these new pairs of rabbits. The original pair of rabbits that was born is too young for the first month, is too young for the second month, but then from that month on, that second pair of rabbits is going to start producing a new pair of rabbits every month. And you can write some stuff down and you'll eventually find this same list of numbers representing how many rabbits you have at the end of each month. At the end of the first month, we have 1, the original pair. At the end of the second month, we still have 1, the original pair, because they're not old enough to reproduce yet. But then going into the next month, they finally start producing and they produce another pair of rabbits. These numbers represent how many pairs you have. So how many pairs do we have in the third month? We'll have 2, the original pair plus a newborn. Is that newborn pair old enough to reproduce yet? No, so they're not producing anything, but the original pair is going to continue churning out a new pair of rabbits every month. So that 2 becomes a 3 in the next month. See it? How come the 3 doesn't just become a 4? Yeah, the pair that was first produced by the original pair of rabbits is now old enough. And so they produce a new pair of rabbits. So 3 doesn't just jump to 4 from the original pair, but jumps to 5 from the original pair's original birth pair. How come 5 doesn't just go to 7? 5 goes to 8. Why doesn't 5 go to 7? Yeah. There are more rabbits that are now old enough to reproduce. You can see it becomes quite challenging to just think it through in your head. It's difficult to keep track of how old these rabbits are. There's also rabbit incest, which is a little bit disturbing. But anyway, that is the list of numbers, surprisingly, that comes out. And so this was his problem. It was actually like this work that he produced here, this Liber Abaci, is well known. This problem right here was just in the appendix. It was almost an afterthought of his, but this is what is associated with his name. Okay, so let's go down to Fibonacci ratios. We're going to say fill in, and who are we up to now? Kelly. Okay, and Iris? Okay, so here's what we're going to do. We're going to fill in the first few together, and then you guys will very carefully fill in the rest. And I say carefully because if you make one mistake, then that mistake carries on for the rest of the problem, right? So we have 1 plus 1 is how much? 2. 2 plus the previous 1 is, first is 3. And then 3 plus 2 is 5. And then 8. We've seen this number, this list before. But all you do is add the 2 previous. Questions on this side of the calculation? Yep, next one is 13. But before you finish this left-hand column, I just want to make sure we're clear on what we're supposed to do over here on the right-hand column. Let's take a look at this one right here. It says F7 divided by F6. What's F7? It's 13. Divided by, what's F6? 8. We're just taking the current number and dividing it by the previous number. That's what it says. F7 divided by F6, 13 divided by 8. 13 divided by 8, you can type into the calculator. $1.625. I'm going to stick a couple of zeros here just to remind you that I would love to see 5 digits at the end of all of these division calculations, okay? Got to give me enough digits if we're going to see the pattern that we need to see. So go through the whole left-hand column. Don't worry about the division first. Just do the left-hand column. Check with your neighbors. Don't get too far without checking in with each other. Then start doing the divisions. When you get to the divisions, that's a good time to split up the work. I don't need everybody to do all 20, right? You don't need to do all 20. So do the left-hand column together, then split up the work on the right-hand column.